5.1, multiplying polynomials. So first what we're going to do is we are going to review some of the skills that we've learned in grade 9. So what a polynomial is it's an expression that is written in this form right here. Okay, this should be 1. Right, so pretty much what we have is some expression where the exponents are positive integers and they're going to be written in descending order. So we could have y equals maybe like 3x to the 3 plus 2x squared. Okay, so 3, 2 for the exponents plus 4x minus 5. Okay, and the constant's always at the end. Okay, so in grade 9, we took a look at monomial and binomial. So what a monomial is it is a one-term polynomial. So I have a couple examples here. X is a monomial, negative 6xy is a monomial, and 4a squared is a monomial. Okay, and just as a little bit of a review, terms are separated by plus or minus signs. So when we take a look at binomials, for x plus 1, okay, 4x and 1 are both terms and they're separated by an addition sign. 2x squared minus 3x. Okay, both of these are terms, again, separated by a negative sign this time. Okay, and trinomials, these are 3-term polynomials. Okay, and there's an example, 4x squared plus 3x minus 1. Okay, and to write a polynomial in standard form means that the terms must be written in order of descending degrees or exponents. So let's rewrite each of the following polynomials in standard form. For a, x squared is going to go first because it's the biggest exponent, and then 3x is going to go next, and then the constant always goes last. So I think that was plus 5. So let's say plus 5. Okay, for b, 9b squared is going to go first, and then 8b, so positive 8b, and then positive 3. Okay, so we have 2, 1, 0. And technically this is 3b to the 0 and 3b to the 1. So we have 2, 1, 0. But when we have an exponent 1, we don't actually have to write exponent 1. It's tedious. And when we have exponent 0, we know that this will cancel out to 1. So 3 times 1 is just 3. Okay, and for the third one, we have negative 7x squared. And don't forget that negative sign. Any sign on the coefficient stays on the coefficient. Okay. Plus 9x minus 3. There we go. Okay, now we're going to talk about degree of a term and a degree of a polynomial. So the degree of a specific term is the sum of the exponents on the variables in each term. I'm going to give you a quick example. If the variable is a squared b cubed, then it's degree 5. This is a d. Degree 5, because it would be 2 plus 3. It'd be the sum on the variables. So now if we take a look at the degree of a polynomial, what we want to do is we want to determine the degree of each term in that polynomial. And then what we do is we just choose the highest degree. And the highest degree will always be the degree of the polynomial. So let's take a look at example 2. State the degree of each term and then determine the degree of the polynomial. So 3x squared, this is degree 2. 2x, that'd be to the 1. So degree 1. And then minus 5, there's no x, so you can put 0. It would technically be x to the 0, but no worries. So the degree of the polynomial, 2, 1, 0, it's going to be 2 because that's the biggest. Okay, 3a, that'd be to the 1, b cubed, c1. The degree of this would be 1, 2, 3, 4, 5. Okay, minus 2a to the 1, b to the 1, that would be degree 2. So the degree of the polynomial in this case is 5. It's the bigger one. Okay, and the last one. This is a constant, so degree 0. This is degree 4, and this is degree 1. In this case, the degree of the polynomial is the largest one, which is 4. Okay, now let's talk about multiplying monomials. So what we first want to do is multiply the numerical coefficients. Okay, so basically just multiply the numbers. And then what we do is multiply the variable. Oh, say variables, okay? And how we multiply the variables is if the variables have the same base, we add the exponents. See this, a plus b? We just add the exponents. So this is a little bit of a review from exponent law in grade 9. So example 3, simplify. First, we multiply the 2 times 3, which is 6. And x and y are not the same variable, so we just write xy. 6xy is also 6 times x times y. These are all just multiplied. Okay, next one, 8 times 3, I get 24. Now we have x to the 2 and x to the 5, so what we're going to do is, these are the same base, the base is x, and we will add those exponents, 24, x to the 7. Okay, next one, 6 times negative 4 is negative 24. Now we have x to the 1 and x squared. So we just add those exponents because they're both base x. Negative 24x cubed. All right, D. 2 times 6 is 12. We have x squared next to the 7, so we want to add 2 plus 7. And then the y is the only y we have, so let's just put in y, and the w is the only w we have, so let's just write down w. So times y times w. Now, I'm going to put these in alphabetical order in the next line. So we have 12w x y, and the exponent on the x is going to be 9. Okay, E. Negative 8 times negative 2, I get positive 16. We get x squared next to the 4. So it's 2 plus 4. Just please note this x is actually a multiplication symbol. It's a very, very upright and sleek x, rather than like the italicized Times New Roman type of x. Okay, then we have y6, y7, okay, y to the 6 plus 7. And when we simplify, we just get 16, x to the 6, y to the 6 and 6 is 12, 13. Okay, and F. 8 times 3, again, 24. We have x to the 3 and x to the 2. So on those two, we want to add the exponents. y4, y1. Okay, so y to the 4 plus 1. And we get 24, x to the 5, y to the 5. So that's a little bit of a review from grade 9, just a little bit exponent laws. Okay, now we're going to review distributive property. So what we want to do is, for distributive property, we're going to get a monomial outside of a binomial. So the binomial, of course, 2 terms, right? And what we want to do is we want to multiply every single term by a. So a is going to multiply by b, and a is going to be multiplied by c. Okay, so we multiply a by every single term in the brackets. Okay, and just to note, the number of terms in our answer is going to be the number of terms in the bracket. So, for example, 4, let's expand and simplify by collecting like terms, okay? So, 4 times x, I get 4x. 4 times 2y, I get 8y. There aren't any like terms, so that one's done. Negative 6 times x is negative 6x. Negative 6 times negative 3, I get positive 18, y, negative 3y. And negative 6 times positive 4w is negative 24w. Okay, we have x, y, w. We could put the w term in front, so negative 24w minus 6x plus 18y, because then everything's in alphabetical order, and that's fully simplified. C. We're going to multiply 8x by x, and we get 8x squared. And we're going to multiply 8x by negative 5y. So 8 times negative 5, I get negative 40. And x times y, I just get pretty much x times y, xy. Okay, and let's keep going. 5xy times x is 5x squared y. 5xy times 3y, well, 5 times 3 is 15. We have x, and then we'll have 2 y's there, y squared. And then 5xy times negative 6w. 5 times negative 6 is negative 30. And then we're going to have wxy. Put those ones in order. Okay? Then also, if you notice, the w, it comes first in the alphabet, so I would put negative 30 wxy first, and then plus 5x squared y plus 15x y squared. All right, let's keep going. So we're going to get used to this. When there's just like a negative sign in front of the bracket, all we do is negate what's in the bracket. So all that means is like take the opposite value. So instead of 3x, we're going to go negative 3x. It's just going to change the sign. Instead of negative 4y, it's going to become positive 4y. And instead of positive 5w, it's going to become negative 5w. And we can put that in order. Negative 5w minus 3y plus 3x plus 4y. Okay, and the last one. X times 2x is 2x squared. X times 3y is 3xy. And x times negative 4z is negative 4xz. Okay, now we're going to expand and simplify. So just one more step onto what we were doing in distributive property. So we're going to expand the 4x into this bracket, okay? And just take note that the 4x only touches that first bracket, and then here, the negative 2 only touches this bracket, so the negative 2 will only be distributed into this bracket. Okay, so 4 times x, and then we have 4 times 2, negative 2 times x, and negative 2 times negative 5. Okay, and then we collect like terms, so I get 2x, and plus 8 plus 10 is plus 18. So this is fully simplified. So this is expanded here, and then simplified means collect like terms. Okay, so for the first bracket, we're going to negate everything. We're going to multiply everything by a negative sign. So negative 3x plus 5y. All that happens is the positive 3x goes to negative, the negative 5y goes to positive. Okay, and we're going to multiply everything in the second bracket by 2. So 2 times 4x is 8x. 2 times negative 3 is negative 6y. And then we want to collect like terms. So negative 3x and 8x gives us 5x. 5y minus 6y, I get negative y. Okay, we'll keep going. 4x times x is 4x squared. 4x times 3y is 12xy. Negative 8x times x is negative 8x squared. Negative 8x times negative 2y is 16xy. Okay, and now we just want to collect like terms. We have 4x squared. 4x squared, and we have negative 8x squared. So I get negative 4x squared. So we have 12xy and 16xy. So I get plus 28xy. Okay, now D. Distribute this into this bracket and this into this bracket. So 8xy times 3x is 24x squared. Okay, because remember that x to the 1 and x to the 1, we add those exponents. Y minus 16xy. Then we have 6 times 8, 48x squared y. And 6 times 4 is 24xy. Okay, Then we want to take a look for, okay, looking for like terms. I see that we have 24x squared y and 48x squared y. So altogether that's 72x squared y. And negative 16 and 24, both of those are xy's. So 24 minus 16, I get 8. So plus 8xy. Okay, in example 6, what we're going to do is we're going to expand first, and then we're going to evaluate when x is negative 2 and when y is 3. So first I'm going to expand the 3 into this bracket. I get 3x plus 6y. And I'm going to expand this negative 4 into the bracket. I get negative 4x plus 4y. Okay, we're going to collect like terms. So 3 minus 4, I get negative x. 6y minus 4y, I get 2y. And now what we want to do is we want to sub these in. So I'm going to bring this negative sign down, and I'm going to bring this x down. Our x is negative 2. Okay, I'm going to bring this 2 down, and this y, which is 3. Okay, so when we distribute that in, or when we multiply this negative 1 times negative 2, it becomes positive. So 2 plus 6, I get 8. Okay, and example 7. So this is the last one of the review, and then we're going to get into real grade 10 stuff. So a rectangle has the length of this 2x plus 1, and then a width of 5x, okay? And we saw a lot of this last year. Write a simplified expression for the area. So we know that the area is the length times the width. So I would like to write the 5x, like the monomial first. So let's call 5x the length, and let's call 2x plus 1 the width, okay? So simplified means that we have to expand and then collect like terms. So I get 10x squared plus 5x. Okay, so that's this right here is a simplified expression for the area of this rectangle. Now let's evaluate our expression when x equals 5. So 10, 5 squared plus 5 times 5. Okay, so 10 times 25, which is 250, plus 25. And this is measured in units, so I get 275 units squared. Okay, so therefore, we can write area equals 275 units squared or squared units.